y equal to fx equal to x minus 3 by 2x plus 1. Z equals to f of y. Now we have to represent z in terms of x. So what we can do? First of all, we see here y, the value of y is x minus 3 by 2x plus 1. F of y means what? X will be replaced by y. So if x is replaced by y, what we get? We get here. Now the value of y we know. This one. Substitute. So this will be x minus 3 by 2x plus 1 minus 3 whole divided by 2 into x minus 3 by 2x plus 1 plus 1. Now that gives you what? X minus 3 minus 6x minus 3 by 2x minus 6 plus 2x plus 1. This gives us what? Minus 5x minus 6 by 4x minus 5. So here does it show that z is expressed in terms of x. Given fx equals to 4x minus 5 by 3x minus 4, and here we have to find f of fx, and we have to show that is equals to x. So here what we have to do, we have to find here f of fx. So now for this function, fx itself is acting like x. So we can start it in this way, that we have f of fx equals to 4fx minus 5 by 3fx minus 4. Now since fx is given, we substitute the value here. There is 4x minus 5 by 3x minus 4 minus 5 whole divided by 3 into 4x minus 5 by 3x minus 4 minus 4, provided 3x minus 4 not equal to 0. Now we take this one, 3x minus 4 as LCM in the numerator as well as in the denominator. So 3x minus 4 is taken as the LCM. So this is 16x minus 20 minus 15x plus 20. In the denominator, what we have? 12x minus 15 . Now we can see this one and this one is getting cancelled out. In the numerator, we are left with x. In the denominator, we are left with 1. So ultimately, this gives us x. It is given fx equals to a minus x to the power of n to the power of 1 by n, a greater than 0, and we have to show here f of fx equals to x. So here also we started in this way, that we have f of fx equals to a minus fx to the power of n whole to the power of 1 by n. Now after that, we just simply put the value of fx, which is a minus x to the power of n to the power of 1 by n whole to the power of n to the power of 1 by n. Now this gives us a minus a minus a minus x to the power of n whole to the power of 1 by n. And this gives us x to the power of n whole to the power of 1 by n, which is x. Hence proved. Given phi x equals to 1 minus x by 1 plus x. Now, what you have to prove in part 1, it is phi of phi x equals to x. And number 2, it is phi of phi cot theta equal to cot theta. Now, when we start here the sum, we can define, or we can just, you can say, redefine the function phi x as we have phi x equals to 1 minus x by 1 plus x, provided x not equal to minus 1. Now what do we have to find? We have to find phi of phi x, and phi of phi x equal to 1 minus phi x by 1 plus phi x, as phi x not equal to minus 1. Now we can substitute the value of phi x, which is 1 minus x by 1 plus x, whole divided by 1 plus 1 minus x by 1 plus x. X should not be equal to minus 1 as phi x is defined. Now if we simplify, it is 1 plus x minus 1 minus x by 1 plus x plus 1 minus x. So this gives us x, which is the first part of the proof. Now once we have proved that phi of phi x equals to x, then we can say phi of cot theta will be cot theta, provided cot theta is not equal to minus 1. We get phi of phi cot theta equal to cot theta, provided cot theta not equal to minus 1. It is given f of x equal to tan inverse of x, and we have to find the relation by which f of x, f of y, f of x plus y are connected. Now, from this, similarly, we can say, because when f(x) equal to tan inverse of x, then we can say in this, so that we have f of x equal to tan inverse of x. So similarly, f of y equal to tan inverse of y, and f of x plus y equal to tan inverse of x plus y. Now we have got fx, we have got fy, we have got f of x plus y. Now what is the relation we have? Now tan inverse of x plus y equal to tan inverse of x plus tan inverse of y by 1 minus tan inverse of x tan inverse of y. Now here just we substitute the values which you have got here. So that gives us fx plus fy by 1 minus fx into fy on RHS and on LHS also. If we substitute the value of tan inverse of x plus y, we get this is the relation between fx, fy and f of x plus y, and that is the required relation. Function phi x is defined as 4 when x belongs to q minus 4 when x belongs to r minus q. Now we have to find phi of 0. Phi of 0 equal to 4. Why 4? As 0 belongs to q. Since 0 belongs to q, according to the definition of the function, we can write phi of 0 equal to 4. Now, I just represent these subpart A so that we can segregate other subparts. Now, phi of 2.4. 2.4 can be written as 24 by 10, which is phi of 12 by 5. Now, when the input is a rational number, output should be 4, according to the definition. Next, subpart C, phi of root 3, which will be minus 4, as root 3 belongs to r minus q. Next, we come to subpart D, which says phi of 3.6, that is phi of 36 by 10, and that is phi of 18 by 5. Now this gives us output as 4 because it's a rational number, p by q form, where they are prime to each other. Next we come to subpart E, which is phi of pi, which will be minus 4, as pi belongs to r minus q. Next we come to F, that is phi of E. Now E is also an irrational number, so not a rational number. E is not a rational number, so what will be the output according to the definition of function? Minus 4, as E is a number lying from 2 to 3 whose approximate value is 2.78. It is a huge value. We are just taking the approximate value. That is, here output is minus 4. Why? Because we have taken E. Now E belongs to what? E belongs to r minus q. Why? Because E is not a rational number. Here, what is E? E is actually, E belongs to r minus q. It is what? It is a Euler number. So E belongs to r minus q. E is said as Euler number, whose actually the value of E, if someone wants to write it properly, which will be represented as n equal to 0 to infinity 1 by n factorial. And E lies between 2 and 3. An approximate value of E is 2.718. Now children, this part it just have represented, this will understand later on. Just you can write it down. This will understand not in this chapter, later on you'll understand. Just you write it down. You will not understand right now completely. Just complete to right now, you will understand only this much. E greater than 2, less than 3, and E is approximately 2.71. Now we come to part G. Phi of sine pi by 4. Phi 1 by root 2. So the output will be minus 4, as 1 by root 2 belongs to r minus q. So that's the end of this sum. Fx is defined as 2x square minus 3 x less than equal to 2x plus 1 when x greater than 2 less than equal to 3. 1 by 2x minus 1 when x greater than 3. Now we have to find f of 0. We take as part A f of 0. F of 0 will be 2 into 0 square minus 3, which will be minus 3 as 0 less than 2. Here, as per the definition given, that when x is less than or equal to 2, we can use this definition. 0 is less than 2, so the input will be 2 into 0 square minus 3. So it is minus 3. Now we move on to next part, f of 3, which we take as subpart B. F of 3, so that will be 2 into 3 plus 1, which is 7, as when x equal to 3, fx equals to 2x plus 1. Next we move on to next part, that is f of minus 2. We take a subpart C, so 2 into minus 2 square minus 3, which will be 2 into 4 minus 3, that is 5, as x, here the input is what? Minus 2, that is less than 2. So the definition this has been used. Next we come to part D, f of 4. F of 4, so this is more than 3. The input is more than 3, so this definition should be used. So this will be 1 by 2 into 4 minus 1, 1 by 7, as 4 greater than 3. So therefore we have used this definition. Next, we come to next subpart, E, f of root 2. Now root 2, that is approximately 1.414, so less than 2. So when less than 2, as per the definition of the function, it is root 2 square minus 3, so that will be 4 minus 3, that is 1, as root 2 less than 2, so we use this definition. Next, we come to subpart f, which we define as f of e. Now e is a number, Euler number lying from 2 to 3, so you can use this definition as for the output of the function. So it is 2e plus 1, as e less than 3 greater than 2. We take f of x equal to x by x plus 2. We have to find those values of x for which the function is undefined. We can think it this one as gx by hx. Now gx is a linear function. It is also a linear polynomial function. So being linear polynomial function, gx equal to x and hx equal to x plus 2 have their largest possible domain as R. That is, domain of GR and domain of H is R. Therefore, domain of F equal to domain of G, domain of G intersection domain of H minus those values of X for which Hx equal to 0. That is R minus X such that X plus 2 equal to 0. That is R minus set containing minus 2. Therefore, Fx is undefined when X equal to minus 2. That is, according to the required question, is undefined when X equal to minus 2. Fx is root under of 4x minus 4x square minus 1. Here the given rule of correspondence, the given rule of correspondence will be defined with the largest possible domain, when 4x minus 4x square minus 1 greater than or equal to 0. And this implies minus 4 taking common, x square minus x plus 1 by 4 x square minus x plus 1 by 4 less than equal to 0. This implies x square minus 2x into 1 by 2 plus 1 by 2 whole square less than equal to 0. X minus 1 by 2 whole square less than equal to 0. Now, there can be less than or equal to 0. So there is only one possibility. Only one possibility that x is equal to half, because a square term cannot be less than 0. It can be only equal to 0. So therefore, we have only one possibility. The domain is what? Domain is set containing half. So the given function is not defined for x belongs to R minus set containing half. Fx is given as x by sin x. So this is of the format gx by hx, where gx equal to x and hx equal to sin x. Being a linear polynomial, being a linear polynomial function gx equal to x is defined for all x belongs to R and hx equal to sin x, which is also defined for all x belongs to R. Therefore, domain of the function gx is R and domain of the function h is R. Now, when we find domain of function f, it has to be domain of the function g, intersection domain of the function h, minus those values of x for which hx is 0. So this is R minus those values of x for which sin x is 0. That means R minus n pi, where n belongs to z. So the given function is not defined for x equals to n pi, n belongs to z. And here we start it as that let fx equals to x square plus x minus 6 divided by 2x square minus x minus 6. We take this as gx by hx, where gx is x square plus x minus 6 and hx is 2x square minus x minus 6. Being a quadratic polynomial, in x, gx and hx are defined for all x belongs to R. Therefore, domain of G is R, domain of H is R. Now, we find those values of x for which hx equal to 0 implies 2x square minus x minus 6 equal to 0 implies 2x square minus 4x plus 3x minus 6 equal to 0 implies 2x into x minus 2 plus 3 into x minus 2 equal to 0. This implies 2x plus 3 into x minus 2 equal to 0. This implies x equal to minus 3 by 2 comma 2. Therefore, domain of f equal to domain of G intersection domain of H minus those values of x for which hx equal to 0. Domain of G induction domain of H is R minus set containing 3 by 2 comma 2 for which H is 0. So the given function is not defined for x equal to 2 comma minus 3 by 2. That is, when x belongs to set containing minus 3 by 2 comma 2. Let fx equals to under root of x square minus 4x plus 3. So the given rule of correspondence, the given rule of correspondence will be defined with the largest possible domain when x square minus 4x plus 3 greater than equal to 0. X minus 1 into x minus 3 greater than equal to 0. We take here number line minus infinity, infinity, 1, 3, plus on the right hand side of the highest critical point, power or sign change, power or sign change. What do we need? Greater than equal to 0. So that means what? For all x belongs to minus infinity, comma 1 union 3 comma infinity x square minus 4x plus 3 greater than equal to 0. Therefore, domain of f will be minus infinity, comma 1 union 3 comma infinity. So the given function is not defined when x belongs to 1 comma 3 open, when x belongs to open interval 1 comma 3. Given fx equals to a plus b sin x, max value of fx is equal to that fx is maximum, when sin x is equal to 1, that is sin x is reaching to its maximum value, and fx is minimum when sin x equals to minus 1. So max fx equal to 7 equal to a plus b. and mean fx equal to 1 equal to a minus b. We mark this equation 1 and we mark this equation 2. Now adding equation 1 and 2. Adding equation 1 and 2. So 2a equal to 8. Therefore a equal to 4. Now putting the value of a, in 1, we get b equal to 3. Therefore fx equals to 4 plus 3 sin x. And we have to find f of pi by 6. That is 4 plus 3 sine pi by 6. That is 4 plus 3 by 2. That gives us 11 by 2. Is the required result.